And to supply this population in a renewable way, the only resource available on a large scale is solar energy. There are two ways of its direct usage. Either photovoltaics, with a photovoltaic effect to produce electricity using photovoltaic panels, which are broadly used in many countries already, or by the production of heat, using solar thermal, with the direct usage of heat either in the industry, residential or commercial usage, or on the other hand, concentrated solar power, using heat to drive a turbine that produces electricity for the grid. Types of solar thermal collectors. A solar thermal collector converts solar radiation into usable heat. There are different types of solar thermal collectors. We can have unglazed collectors for low temperature applications like swimming pools and no glass. We can have flat plate collectors for medium range temperatures up to 160 degrees and suitable for domestic hot water production with a glass cover. We can have vacuum tube collectors also for domestic, commercial and industrial applications with a slightly higher operating temperature. And we can have parabolic trough collectors within concentrated solar power that can reach much higher temperatures within 400 to 600 degrees commercially nowadays. And these are also suitable to produce electricity via solar thermal processes. A typical flat plate collector has a casing, a sealing part, it has a transparent cover, normally glass, it has insulation, it can be both on the back side and on the sides of the collector. It has an absorber plate, normally made of a well-conductive metal, being copper and aluminium the most used ones, but it can also be a polymeric absorber, and some pipes where a fluid flows in. On the other hand, a glass tube collector has vacuum inside to reduce losses. It also has an absorber with the pipe and a selective absorber plate. It also has a certain media flowing through the pipe, and the solar radiation is then concentrated into the absorber, and from there it is transmitted into the fluid. This absorber plate has a certain high selectivity coating which allows to have a high absorption while at the same time a low reflectivity. Here is an example of 3 vacuum pipes installed in a manifold of a solar thermal collector. The basics of the solar thermal means that we have solar radiation, a certain amount coming from the atmosphere, normally 1000 watts per square meter. Part of this radiation is reflected by the cover, normally glass. Another part is conducted through the glass, and from all the radiation that passes the glass, dependent on the transmissivity coefficient of the glass, a good part of it reaches then the absorber. And from the absorber plate, by means of a fluid flowing through the pipes of the absorber, we can then collect a certain amount of energy. This is then the so-called usable fraction. Additionally, we also have losses by means of convection and conduction. A solar absorber absorbs a significant amount of energy, both in the short and long wave range. And the idea is that this absorber, which is fairly hot, should have an insulating material just behind so that it should not lose energy from its backside. On the other hand, in the front part of the collector, we have a transparent cover which allows the thermal radiation to flow into collector along the so-called aperture area. The selectivity of this absorber is then very important. It is a ratio between the absorption, so the amount of radiation that I can absorb in my absorber plate, and the amount of radiation that this absorber emits back to the atmosphere. We divide solar thermal applications into 3 different ranges: low temperature systems, around 50 degrees, swimming pools or for agriculture; medium temperature for domestic hot water, space heating, and some industrial processes. And this, we are in the range of 80, 100, 120, eventually 150 degrees. And we have high temperature systems for industrial processes, desalination, space cooling, and to a higher level, even electricity production.